Find the cube root of the product. That is your question. So the given number here is 6561. Now if you recall, similar question was there in square roots. The question used to be, is a number was given, is this a perfect square? If not, find the smallest number or the least number by which the given number has to be multiplied to get a perfect square. Okay, now this question is exactly the same as your square number question. Okay, so except that you have a cube here. So 6561 question is 6561 a perfect cube? Let's check whether 6561 is a perfect cube. So what you do here is you prime factorize 6561. First factor should be 3. Again with 3 to give you a 729. And again with a 3 to give you a 243. This number is again divisible by 3, give you an 81. Again this is divisible by 3, and give you 27. Again this is divisible by 3, again by 3. So all only 3's you are getting. So let's see what triplets are formed. This is one triplet that is formed. This is another triplet that is formed. Okay. And does this form a triplet? No, this does not form a triplet. So therefore you write 6561 is equal to first triplet, next triplet, and finally you don't have a triplet. You have a doublet here. Okay, you don't have a triplet. Okay. So what you do? What can you say? You can write this as 3 cube. You can write this as 3 cube. And you can write this as 3 square. Now you can add up the powers if you want. 3 plus 3 plus 2. So this will give you 3 to the power of 8. Now if you see, this 8 is not a multiple of 3. Is this a multiple of 3? This is not a multiple of 3. So therefore we say 6561 . Okay, not a multiple of 3. Therefore we say 6561 is not a perfect cube. Or what you can also do is, from here you can see that this is a triplet, this is a triplet, but this does not form a triplet. This does not form a triplet. So therefore, you can, from here only you can say, without even doing all this, you can say 6561 is not a perfect cube. Okay. The next part of the question here is, if not, find the smallest number by which 6561 is to be multiplied to get a perfect cube. So by what number has this to be multiplied to get a perfect cube? So again we look at the prime factorization. Okay. Again we look at this prime factorization here. The prime factorization here of 6561 is, this is what we had got. Okay. The question here is, by what smallest number it has to be multiplied. So if you see here, this is a doublet. Okay, just as we were doing in square roots, this is a doublet. We want to make it a triplet. So what do? We multiply. In order to make this pair a triplet, we can multiply this by 3. But if I'm multiplying this by 3, I need to multiply this also by 3. So therefore, what you do is you multiply both sides by 3. Therefore, 6561 into 3 is equal to 3, this second triplet, and you complete this triplet. We have completed this triplet by multiplying this 3. Okay. So now therefore, this becomes, after multiplying by 3, 6561 will become a perfect cube. So what you do, answer, first part of your answer is 6561 should be multiplied by 3 to make it a perfect cube. Okay, so that answers your first part of the smallest number by which 6561 is to be multiplied to get a perfect cube. So after multiplying by 3, what is the resulting number? Therefore, resulting number after multiplying by 3, resulting number is 6561 into 3. Okay, which will give you 19683. So 19683 is a perfect cube. Therefore, what can you write from here? From this step, what can you write? Therefore, 19683 is equal to 3 into 3 and this triplet and this triplet. Okay. The third part of the question is, see here, find the cube root of the product. What is the product here? This resulting number is the product, right? After multiplying by 3, we get 19683. This is your product. We need to find out the cube root of 19683. What you do is, you write 19683 in form of these three triplets. So this is 3 cube into 3 cube into 3 cube. This is 3 to the power of 3 plus 3, which is 3 to the power of 9. Now, 3 to the power of 9, if I want to express this as a power of 3, what will I do? I can write 3 as 3 to the power of 3 into 3, which will give you a 3 cube whole cube. Because you know that a to the power of m into n or mn is equal to a to the power of m into a to the power of n. Okay. So therefore, what is the cube root of 19683? It is the cube root of 3 cube whole cube, which is simply 3 cube, which is 27. Is this problem clear? Or any question from any part of this problem?
Yes, sir. No doubt.
And I'll proceed to the next one. The question here is, again, same type of question, just as we had in perfect squares. The question here is 8748 a perfect cube? So we need to check. Again, we'll prime factorize and check as in the usual manner, whether we are getting triplets or not. Next part is, if not, find the smallest number by which 8548 must be divided. In the previous question, we had multiplied, right? In this question, we have by what number it should be divided to get a perfect cube. Fine. And the question is, find the cube root of the quotient. So in the previous question, we had find the cube root of the product, and the product that we had got was 19683, because we are multiplying 6561 by 3 to get the product 19683. This time, by what number I must divide 8748? 8748. By what number should it be divided? So whatever I divide, the quotient that I must get something after division. Okay. Yeah, I need to find out the cube root of this number. Okay. So let us now first check whether 8748 is a perfect cube. So we prime factorize. this should be so this is the prime factorization. How many triplets are we getting here? 3 makes a triplet. This is one triplet. This is another triplet. Where we don't get a triplet is with this, and this is a triplet. This does not form a triplet. Okay, so this 3 is alone, and this 2 only forms a pair. It does not form a triplet. Okay, so therefore all the prime factors, equal prime factors, do not form a triplet. Therefore, it cannot be a perfect. So we write therefore 8748 is equal to, we write the triplet first, 3 into 3 into 3 into 3 into 3 into 3 into 2 into 2 into 3. Okay, this is what your prime factorization is. So from here we can write, since all the prime factors, equal prime factors, do not form a triplet, therefore it is not a perfect cube. Or you can proceed in this manner also. You can write this as 3 cube, write this as 3 cube, you can write this as 2 square, and you can write this as 3. So now what happens, you can add up the powers of 3, 3 plus 1 into 2 square, and you can write this as 3 to the power of 7 into 2 square. So what you see here is that both of these are not multiples of 3. Both of these are not multiples of 3. So therefore you can write 8748 is not a perfect cube. Right, 8748 is not a perfect cube. Okay, in fact you can conclude from here only, as I said earlier. Fine. So now let us proceed to the next part of the question. If not, find the smallest number by which 8548 must be divided. Now if you see this 2 into 2 and this 3, they do not form a triplet, right? So if I am able to remove these, then I'll only be left with these two, which is a triplet, right? So that means whatever, if I remove this 2 into 2 and into 3, then I'll get a perfect cube, because of I'll have only two triplets here. Okay, so I'll get a perfect cube. So how do I remove these
Sir,
two? 2 into 2 into 3.
divide by 2.
Divide both sides by 2 into 2 into 3. So dividing,
Yes,
so
sir.
we write first, we have 8748 is equal to, dividing both sides,
Sir, by or directly we can't divide it by 12.
yes, same thing,
Okay, sir.
8748 divided by 2 into 2 into 3 is equal to, so I have divided both sides by 2 into 2 into 3. Okay, so that means So what do I write here? I'll write 8748 must be divided by 2 into 2 into 3, which is equal to 12, to make it a perfect cube. Okay. So that answers your second part of the question. If not, find the smallest number by which 8748 must be divided to get a perfect cube. And what is the smallest number? My smallest number here is 12. Okay. Now the third part of the question. Find the cube root of the quotient. What is the quotient here? Therefore, quotient, just as we are having a product in the last question, what is the quotient here? Quotient is this one. 8748 divided by 2 into 2 into 3. Okay. You divide this, you cancel everything. Okay, you cancel, you get 4, you get 3, 7, 4. And you cancel this, you get 2, 1, 8, 7. And then you cancel this, you get 7, 2, 9. You're getting 729. This is your quotient. Okay, so therefore, what are you getting here? Therefore, from this step, what can you write? You can write 729 is equal to, here also, this 2 will cancel. All this will cancel. So 729 you're getting as 3 into 3 into 3 into 3 into 3 into 3. Okay, which is 3 cube into 3 cube, which is 3 to the power of 3 plus 3, which is 3 to the power of 6. Now 3 to the power of 6 I want to express as a cube. So what I do is I break this as 6 as 2 into 3. So now I can write this as 3 square whole cube. And this is because you know that e to the power of m into n can be written as e to the power of m whole to the power of n. Okay, that is why from this step I could write this step. So I've expressed 729 as a power of 3. So therefore, what is the cube root of 729? Cube root of 729 is the cube root of 3 cube. So now that means 3 square whole cube. So therefore, now you have a power 3 and you have a cube root here and you have a power 3 here. So you can remove the radical. So this simply becomes 3 square
गेट बंद कर
and this becomes 9. Okay. So that answers your third part of the question. The third part of the question was find the cube root of the quotient. The quotient was 729 and we have managed to find out the cube root of 729 as 9. Any question here?
No, sir.
No, sir.
No, sir.
So let us do the next question here. The next question is an easy question somewhat. Okay. The question here is two numbers are in the ratio 4:5. Any two numbers are in the ratio 4:5. If the difference of the cubes is 61, find the numbers. Okay. So two numbers are given to be in the ratio 4:5. This is the ratio of the numbers. That means if the ratio of the numbers is 4 and 4:5, you can take one number to be 4x and the other number to be 5y. So I assume let the two numbers be 4x and 5x. Okay. So next part of the question, if the difference of their cubes, so if the one number is 4x, other number is 5x, which is the higher number? 5x is the higher number. Which is the lower number? 4x is the lower number. Okay, so what is the cube of 5x? Therefore, cube of 5x is 125 x cube. And what is the cube of 4x? It is 64x cube. What is the difference? Difference of their cubes. When we take difference, we subtract what? The lower number from the higher number. Now, since 5x is the higher number, 4x is the lower number, so therefore the cube of 5x, which is 125x cube, this has to be the higher number. And the cube of 4x, this has to be the lower number. So difference is higher number, 125x cube, minus the lower number, 64x cube. Okay, so this comes to 61x cube. The question here is find the numbers. The difference of the cubes is given to be 61. So what is the difference we have got? We have got the difference as 61x cube. And the difference of the cubes is given to be 61. So therefore this 61x cube must be equal to 61. And that means x cube is 61 by 61. That means x cube is equal to 1. That means x is equal to cube root of 1, which is equal to cube root of 1 cube, which is equal to 1. Cube root of 1 is 1, we all know. Okay, so we got the value of x as 1. So what is the first number? Numbers were in the ratio 4:5, right? Numbers were in the ratio of 4:5. So first number was, we are assumed to be first number we are taken as 4x. So we write the first number 4x. First number is equal to 4x and the value of x we have found as 1. The first number is 4. What is the second number? Second number is
5x.
5x. So 5 into 1. The two numbers are 4 and 5 respectively. Okay. So that finishes with your this question. And the next question is evaluate cube root of 27 plus cube root of 0.008 plus cube root of 0.0064. So let us attempt this question. Another easy question, not a difficult question. We have done this kind of question in square roots also. The only difference is instead of square root, we have a cube root here. So we have cube root 27 plus cube root plus cube root. Okay, you need to find the value of this or evaluate this. So what you have? Cube root of 27. You know 27 is 3 cube. So you directly write 3 cube. And you have a decimal number here. So you change this decimal number to a fraction. So 8. And how many zeros? You are shifting how many places of decimal here? 1, 2, 3. So you'll have 3 zeros. Okay. And again here. Again, how many decimal places we are shifting? Again, we are shifting 3 places of decimal. So we'll have 3 zeros here also. Okay. Now cube root of 3 cube. Here I have a power 3. Here I have a cube root. So now you can remove the radical. You're simply left with 3 plus cube root of 8 divided by 1000. You can write this as 2. This cube root of 2 cube. 8 is 2 cube and 1000 you know is 10 cube plus again cube root of 64 you know is 4 cube is 64 and 1000 is 10 cube. So 3 plus cube root of this fraction entirely, you can write it as the power of 3 because both are numerator and denominator is the power of 3. You can write this as 2 by 10 whole cube. And this, you can write this as 4 by 10 whole cube. Okay. And this, therefore, this becomes now this entire fraction, 2 by 10, this entire fraction is a power of 3. So you can simply write this as 2 by 10 plus, and this entire fraction is a power of 3. 4 by 10. This entire fraction is a power of 3 with a cube root. So therefore, this can be written as 4 by 10. Okay, so you cancel this with 2, cancel this with 2. So you get 3 plus 1/5 plus 2/5. Now you can take the LCM. So you get 3 into 5, 15 plus 1 plus 2. So you get 18 by 5. Okay. So this is your answer. Either you can proceed this way, or what you can do is, I hope you are able to understand. Any question in this step? If you don't have any question,
No,
then
sir.
what you can do is you can proceed instead of proceeding this way, you can also proceed this way. It's the same thing actually. What you can do is you can write this as, from here you can write this as, you can separate the numerator and the denominator. Okay. So this you get cube root of 2 cube is simply 2. Cube root of 10 cube is 10. And the cube root of 4 cube is 4. And the cube root of 10 is, that comes to the same thing. Now again you cancel this and you can take the LCM again. Okay. So only difference is here I have separated the numerator and the denominator. There I had taken the cube root of the entire fraction. Okay. So I stop here for today.